This is a project using the HC-SR04 ultrasonic sensor along with a pressure, temperature, and humidity sensor, which also measures altitude, the Bosch BME-280. And we're going to go down we're at 30 centimeters now. We're going to look at the reading 29 or 30.11. And we're going to move down 5 centimeters at a time. So what we have is the speed of sound corrected for temperature and humidity, which should give us a more accurate reading. So we're at 30 centimeters, 30.00, 29.9. Okay, pretty good. Move down to 25 centimeters. 25.04, 29, 24.9, 25, 25.04. Okay, pretty close. Move down to 20 centimeters. Try to get it on the money here. A little better than that, okay. 20.4, 20.03, kind of moving around a little, probably a little bit of noise there. 20.03, 15 centimeters. A little closer than that, okay. 15 centimeters, 15.4, 7, 15.47, 15.33, okay. Down to 10 centimeters. 10.14, 10.14, okay, that's good. 5 centimeters. As close as I can. 5.28 centimeters reading. And I'll go down to, let's go take the 2 centimeters. See what we get here. Okay. 2.4. 2.4. Pretty consistent. Looks like if we put a correction or a calibration, looks like at most they're probably like 0.3, 0.4 high. Okay, let's take a little closer look at the OLEDs and the data that we're getting back. And we have the obstacle here at the 30 centimeter mark. And it's read 30.56. So that's the data that we're also getting back. And we're making that correction for the speed of sound, which should give us a more accurate reading as far as distance. The Bosch sensor can also be hooked up as a serial peripheral interface or an I2C. So you can use either one depending on your application. Here we're using it as a serial peripheral interface, SPI, and along with the OLEDs, which are I2C. Let's take a look at the code. First, we are setting up some constants for our ultrasonic sensor for the trigger pin and echo pin. Then we're setting up some libraries, and these will be set up for the wire library,
I2C for our two OLED displays and the SPI library for the BME280, along with its accompanying other libraries that facilitate its function. Then we're setting up objects for the OLED display here. Display 1, display 2. Then we have the setup for the SPI, which we're going to be using SPI on the BME sensor. It can also be used as an I2C, but we're going to be using it serial peripheral interface in this setup. And that's all the defaults here for that, for the pin assignments. It also is able to do what they have here as a software SPI, where you can actually, these are the defaults, but if you go software, you can actually redefine these pin assignments if needed. Right here, we're going to set up sea level pressure for our pressure reference for our altimeter. The BME-280 can also act as an altimeter, which give you actually elevation. But to get the correct elevation, you need to know the sea level pressure for the area that you're going to be operating in, similar to an airplane. So they always take a altimeter reading, and this station here is an actual website for aviation, where they actually report sea level pressure in millibars, exactly what this is looking for. So sometimes you can just use just a standard reference. 1014.3 is probably be pretty close, but easier to get it. If you want to get it exact, you can go to this website or any other weather service that might provide the sea level pressure in millibars, or you can do a conversion. So we comment out the stuff we don't need. We're not using I2C, and we're not using the software SPI, so we'll go with the hardware SPI, and the only thing we'll be setting there is the chip select at pin 10. Then this is going to be our delay time. We're going to run through the loop every 500 milliseconds. Then in the setup mode, we have the pin mode for our ultrasonic sensor, trigger pin out, echo pin in. Then we're going to set up the serial monitor at 9600 for troubleshooting. And we're going to make sure the serial port is ready. We're going to wait until it's ready, and then we're going to move on. And this is essentially going to print on the serial monitor a space. And then BME begins going to take effect, and it's going to go out and look and see if it can find a BME-280 on the SPI bus at hex 77. If it can do that, which we hopefully it will be able to find it, this will be true. The status will be true. And then when we get to this line where it's looking if not true, if it's not true here, be false, and then if not true, well, this will take effect, this if statement, and it'll print out on the serial monitor that you should check the wiring and address for your sensor. And it'll stop everything right there with this while 1, which is while true, and that'll just put it in a loop, and then you'll try to find out where your wiring problem is and take care of that. Here we're going to set up the address, since we got two I2C devices on the same central bus here. We've got one at hex 3C and the other at hex 3 delta. Then we're going to go into the loop. The loop is essentially just some function calls. Print values, which is responsible for printing values on the serial monitor. Print OLED 1, which is responsible for printing on the OLED 1. And print OLED 2, which is responsible for printing on OLED 2. And take a look at some of those user-defined functions. The print value, like I said, it's going to print to the serial monitor the temperature, pressure, altitude, humidity, and distance to the target that we're shooting for or arranging for. Then we're going to look at print OLED 1, which is going to print to OLED 1, essentially the pressure, or the temperature, pressure, humidity. OLED 2 is responsible for printing out the correct speed of sound with respect to the temperature and humidity currently, or the current temperature and humidity. It's also going to call another function called getRange, where we're actually going to get the distance to the target. And get range is going to go through whatever it needs to do here to trigger the ultrasonic sensor in order so it can get a pulse back. And we're going to do a pulse in command. We're going to read the time of that pulse, or the on time of that pulse. And we're going to do a correction here for, again, humidity, temperature with this equation here. And that's going to give us, hopefully, the correct speed of sound in meters per second with respect to the current conditions. And then we're going to do a little conversion here, and we're going to take that meters per second and convert it down to centimeters per microsecond. And we're going to come out, multiply that times the pulse time, and it's going to give us a distance in centimeters, which you're going to pass along back to the OLED 2 function here. And that's going to print it on OLED 2. Let's take a quick look at our layout. We have the BME-280, our Arduino, our two OLED displays, and ultrasonic sensor. Pretty straightforward on the wiring. We're wiring the BMP-280 directly to the SPI interface right here on your board, which is at the back end of that board. And we're going direct there, and everything is just as laid out here. Pretty simple. And another thing to note on these I2C1, these serial interface, you can always use these two pins, these two outer pins, power and ground, to support other activity that you're doing on the board, because they're kind of convenient since you only have here, I think they just have one here. So if you need power, you always feel free to use these two pins on this interface if they're not being used for anything else, because everything 5 volts is bused to the same thing. That's ground, 5 volts ground, which we use that here. That's it for this project. The documentation and code is below. Thanks for watching.